All right, 22E, linear representation of non-linear relationships. So hopefully as we go through this, you'll start remembering stuff. I think it was chapter 5, so way back. Yeah, it was, there you go, chapter 5, data transformations. Look at the graph, y equals 3 over x. That's what the graph looks like if we're just drawing it in the positive, so x and y are both positive. 3 over x looks like. Clearly, it's a curve. Now, if we put the table of values in, if x is 0, 3 divided by 0 is infinity, so this means there's no value here. 3 divided by 1 is 3, 3 divided by 2 is 3 over 2, 3 over 3 is 1, 3 over 4, 3 over 4 is 3/4, 3 divided by a half I think is 6, and 3 divided by a quarter I think is 12. So here's the table of values. Now, clearly this graph is non-linear, it's curved. We want to make it into a straight line. So what we're going to do is going to add another row to the table. The row we're going to add is 1 over x. Because if you think about it, this graph is a k over x graph, isn't it? 3 over x. So we're just going to work out what 1 over x is. So 1 divided by 0, again, that's going to give us an error, so we're probably not going to do that one. 1 divided by 1 is 1. 1 divided by 2, 1 divided by 3, 1 divided by 4. 1 divided by a half is 2, and 1 divided by a quarter is 4. So there's our new. So now if we plot 1 over x against y, we get a straight line. So there's our original one, and there's 1 over x against y. Straight line. And we can answer some questions about that. So what's the gradient of this graph? So we'll just use our gradient formula. We'll use these 2 points here. So y2 minus y1, x2 minus x1, 12 minus 6 is 6, 4 minus 2 is 2, 6 divided by 2 is 3. So the gradient of that graph is 3. So they'll ask you questions like that. So here's one where they specifically asked us what to do. They told us to plot the graph and determine the value of k and c. So here's the table. And we've added in this row here. So it's told us to plot the value of y against x squared. So it's told us to do that. So we've got to add that extra row to the table. Now we're just plotting y against x squared. So here's our y values, and there's our x squared values. Okay, could be doing this on a calculator if you want. So we plotted the graph, got our mark there, determine the value of k and c. So the y-intercept is 0.5, and we can tell that because it's 0.5 there. So take real careful, because when I first did this, the intercept is 0. Oh yes, it looks like 0, doesn't it? But don't forget we've got the table of values here that tell us that the intercept is at 0.5. We've got the gradient is 2.5. So how do we do that? We just use the rise over the run. So I use this point here and this point here. Could have used any of the 2 points. And 123 minus 63, 49 minus 25 is 60 over 24, which comes to 2.5. Now, don't it says determine the values of k and c. So even though we've worked out c and we worked out k, we've got to write the answer. So we've got to write thus, or something like the value of k is 2.5, the value of c is 0.5. So take care that we've actually written the answer to the question. Sometimes they'll be asked to find a rule. So here's an x value, here's a y value. Now this is quite a tricky example, and I've never seen an exam question as tricky as this. So if you can follow this, you should be fine. So the first thing we'll do is going to get our CAS turned on, and we're going to type those values into the spreadsheet. So my x values and my y values. I'm then going to draw the graph. That's my x and that's my y. Now I can clearly see that this is a curve. So it looks like it's going to be y in the form kx to the n. So it could be an x squared graph. Yep, that's what x squared looks like. Could be an x cubed graph. So it's one of those two. And we're going to guess x cubed. Okay, now usually in the question they will tell you what to guess. So like I said, this is a more tricky one. So we're guessing that it's going to be x cubed. So what we're going to do is we go back to the spreadsheet and we're going to type in an x cubed column. So this is what we did in chapter 5. So we've got our x and our y. We've called this one x cubed, and then we've got equals this value here, x all cubed, and it should do it all for us. So if you're having trouble, go back to the chapter 5 spreadsheet, PowerPoint, chapter 5 PowerPoint. It explains this in a lot more detail. So now we've got our y and our x cubed. So we've done this before. So now we've got this one here is called x cubed. This one here is y, and we can see we've got a straight line. So if we now go and put in our regression line, we get the line y equals 0.000102 plus 3.499999x. Now, that's a really, really small number. So we've got to consider that to be 0. R equals 1, which means it's a perfect straight line, doesn't it? So the equation of this line is actually y equals 3.49999 is roughly 3.5, and it says y equals 3.5 x squared. That's the answer there. So I put in a couple of extra questions. This one here is a extended answer question. It's a good one to do. Going back to 2017, back to 2016, and there's a multiple choice question. Thursday's lesson, we're going to have a revision lesson. So I'm going to give you a revision thing to do on Google Classroom that you can do during class. On Friday, we've got a test. Don't forget, so for you to prepare for this test, to do really, really well, which I know you all want to do really, really well, make sure you've done all the exercises. Make sure you've done all the exam questions, the 21 exercise, chapter 21 as well. 2 chapter reviews. There's 4 skill sheets here, 2 in chapter 21, 2 in chapter 22. Seems like a lot of work, doesn't it? But hey, it's worth it. You're going to get yourself an awesome, awesome, awesome score in further maths for VCE. Okay, Mr. Patch, over and out.